Those who have joined the class can give their attendance in the chat box. I repeat, those who have joined the class can give their attendance in the chat box. So it is 1:15 p.m. I will not wait further. So let us start the class. See, many of you have not joined the Google Classroom for design theory part as well as the lab part. So if you have not joined the Google Classroom, please join it by today. Today evening I will post that Google Classroom code. With that code you can join, because all the lectures, recorded lectures, whether it is of lab or it is of theory, I am giving in that Google Classroom only. All the materials related to theoretical class as well as the lab class, I am giving it in that respective Google Classroom only. Fine. So those who have not joined the class, please join it by today. Today after 5:30 p.m. I will give you the Google class code. With that code you can join the class. So let us start the class. So give me a minute. Let me present my screen first. I can see only 12 people have given the attendance. So far 16 people, 15 have joined. So please give your attendance in the chat box if you have not given. Can you please answer whether my slides are visible or not?
Yes,
Yes,
sir.
sir.
Yes,
Visible.
sir, visible.
Okay, fine. So far we have done two experiments. That is, the first experiment that we have did was the analysis of a 4-bar truss member. The second experiment which we have did in the last class, was the analysis of simply
Beam.
supported beam. And in today's class, we will be performing the third experiment, that is the torsional analysis of a shaft. If I am having a shaft, that too we are taking a composite shaft of different length and of different diameters. On this shaft, if you apply a torque, then how the twisting is happening, how much will be the shear stress generated in the entire shaft member, all these things we will analyze today by this ANSYS software. So all of you, please note down this diagram and these points what are there in the question, because otherwise what will happen is that again if I try to open this PPT, something will not work in that ANSYS. Again I have to start from the beginning. So please, in a piece of paper or in a copy, note down the important points of this problem. Fine. So that next time what I will do is that I will not open this PPT. I will directly open that ANSYS and you will tell me all the given data which is there in the problem. Fine. Okay. So let us start the class. Read the problem. What the problem is? The problem is a solid stepped shaft of circular cross section is shown in the figure. Modulus of rigidity of the shaft material is 7 into 10 to the power 4 Newton per millimeter square. Since we are talking about torsional strength of the shaft, so I will not talk in terms of E. Here I have to talk in terms of G, that is modulus of rigidity. 3D linear finite strain beam element, beam 188, is used to perform the analysis. The type of beam, definitely the cross section will be circular, but the type of beam which you have to use for this analysis is given in the problem, that is 3D linear finite strain beam element, number beam 188. Poisson's ratio for the shaft material is 0.33. That means the value of mu is given to you. If the value of mu is not given to you, you can find it out from the relation E is equal to 2G into 1 plus mu. If E is given to you, if E is given to you in this problem and G is given to you, then you can find out by the relation E is equal to 2 times of G 1 plus mu. If mu is directly given in the problem, not a no issues. The shaft is subjected to a counterclockwise torque of 3 kilonewton meter at a distance of 450 mm. So if you see in the diagram, so this is the 450 mm length at the junction of 450 mm and 400 mm. That means at the junction of 100 mm dia shaft and 80 mm dia shaft, a torque is applied in anti-clockwise sense and the magnitude of torque is 3 kilonewton meter. And a clockwise torque of 2 kilonewton meter is applied at a distance of 850 mm. That means 450 plus 400, 850 mm. That means this 2 kilonewton meter clockwise torque is applied at the junction of 80 mm diameter shaft and 50 mm diameter shaft. Use ANSYS software to animate the problem. That means due to this application of torque, how the twisting is happening, animation view, you have to show. This already you have did in the last experiment in case of beam, how to animate you know already. Also plot and list the rotation of nodes. In this problem, nodes will not get displaced, nodes will rotate because you are applying a torque. So torque will create or will make the node of each and every element to rotate. So there will be no displacement, there will be rotation of node. This should be clear in your mind. Secondly, the shear stress in the shaft cross section, that you need to find out, as well as you need to show it, you have to plot it, and the reaction torque at the end. If you see the shaft, the entire arrangement of the shaft is fixed at both the ends. So definitely there will be some fixing moments. There will be some Definitely there will be some fixing moments at both the two fixed end of the shaft. That also you need to find it out. And the 100 mm dia shaft is of 450 mm in length. 80 mm dia shaft is of 400 mm in length and 50 mm dia shaft is of 500 mm in length. Is the question clear to you?
Yes, sir.
Other people please respond whether any doubt is there or not in the question.
Clear, sir.
No, sir.
Okay, so let us solve the problem. For that, first of all, I have to identify the nodes of the problem, because normally so far what we are doing with the help of nodes, we are modeling the entire geometry. So first let us identify the nodes of the problem. So can anyone tell me how many nodes will be there?
Sir, 4 notes.
Four.
Four nodes. Yes, there will be total 4 node. One node will be this one. Second node will be this one. That is node number 1, node number 2. Third node will be this one, node number 3, and the fourth node will be this one. So total how many elements are there? Can anyone tell me total how many elements are there?
Sir, three.
3 elements. That is, this is my element number 1. This is my element number 2. And this is my element number 3. Okay. So in order to model the geometry, first I need to find out what? I need to find out the coordinate points of the node. Then I will import those coordinate points. After that, we will import in between the two nodes, there will be one shaft whose cross section is circular. Fine. So can you tell me what will be the coordinate points of nodes 1, 2, 3, and 4?
Sir,
Node
for
1.
one that is 0, 0.
Okay, let me write over here. Wait, let me write. Node 1 is 0, comma 0. Okay, node 2,
0,450.
450, 0.
0, comma 450. Okay. 0 comma 450. That means I am assuming this to be the reference portion, reference plane. This is my y, this will be my x, and this will be my z. Okay, then third nodal point coordinate.
450 नहीं होगा?
Oh, sorry. 0, 450. Sorry, by mistake I have written. Okay, this will be 450, 0. Yes. Coordinate of third nodal point.
850, 0.
It will be 450 plus 400, 850, 0. 850, 0. Fine. The fourth nodal point.
1350, 0.
450 plus 400 is 850. 850 plus 500 is 1350. Correct. 1350, comma 0. Please note it down somewhere because I will be closing the PPT afterwards. Then you have to tell me all these values while importing in the ANSYS. Is it clear to all of you? All these
Yes,
four
sir.
coordinate points? Okay.
Yes, sir.
Okay, fine. So here I have mentioned nodal point 1. This is the coordinate in x, y, and z axis. Nodal point 2. Coordinate is 450, 0, 0. Nodal point 3. Coordinate is 850, 0, 0. Nodal point 4. Coordinate is 1350, 0, 0. Next step is we have to tabulate the element attributes. And what do we mean by element attributes? By element attributes, we mean what is the value of E, what is the value of G, that is modulus of rigidity, what is the value of Poisson's ratio for all the materials. Since if you see in this problem, for all the element, there is a common Poisson's ratio as well as there is a common shear stress. So for all the element value of modulus of rigidity. So for all the element values of modulus of rigidity as well as Poisson's ratio is also same. That is 7 into 10 to the power 4 Newton per millimeter square. That means 70,000 Newton per millimeter square. And Poisson's ratio value is 0.33. I have tabulated. The last step is to, okay, let me delete everything. Last step is you have to tabulate the boundary and loading conditions, because after modeling the geometry you need to apply the boundary and loading conditions, then only ANSYS can solve this problem. Fine. So can you tell me from the diagram what are the boundary conditions and loading conditions present in this problem?
So two ends are fixed.
Sir, 2 kilonewton meter moment at node 3
Yes, 2 kilonewton
and
meter moment is acting at nodal point 3. Okay. Second loading
clockwise.
condition, clockwise. Yes, very good. Sense is clockwise. Okay. And second
2
loading
kilonewton
condition,
meter at node 2 anti-clockwise.
yes. At nodal point 2 in anti-clockwise direction, moment is acting, that is 3 kilonewton meter. And I also know from the concept of strength of material that if you are taking clockwise moment positive in the problem, you have to take anti-clockwise moment negative. Or if you are taking anti-clockwise moment positive, you have to take clockwise negative. So let us take any one positive and any one negative. So here I have taken -3. That means I have taken the anti-clockwise moment negative and I have taken clockwise moment positive. You can do the vice versa also, not an issue.
So
So
both ends are fixed. ये भी एक
wait,
होगा.
wait, wait, wait. So at node point 3, this is the moment acting anti-clockwise negative, and at nodal point 4, this is the moment acting clockwise positive. Yes. Next boundary condition. So this we have
Sir, node
completed
point 1 and 4 are fixed.
node point 1 and node point 4 is fixed. If node point 1 and nodal point 4 is fixed, then what will be 0?
Displacement will be 0.
Sir, rotation.
Displacement due to torque, nobody can displace in nature. So don't use the word called displacement. Torque creates twisting in the body. So body will twist. So here you can say that the nodal points will rotate. Don't say displacement. That means rotation of nodal point 1. That means this particular nodal point. That means this particular nodal point 1 and nodal point 4 will be 0 in all the axes. Yes or no?
Yes, sir.
Sir, can you
So,
just repeat this
right?
point?
Sorry?
Sir, can you repeat this point?
Yes. If you see in the diagram, both the two ends are fixed. If both the two ends are fixed, then nodal point 1 and nodal point 4 will not rotate. That will be fixed. If there is no rotation, then theta will be 0 for nodal
Yes,
point
sir.
1 and for nodal point 4, and that theta will be 0 for all along all the axis. If you take x axis, if you take y axis, if you take z axis. And in ANSYS we represent rotation by this symbol R O T, then suffix x for x axis, suffix y for y axis, suffix z for z axis. So I can write for nodal point 1 rotation x, rotation y, rotation z 0. For nodal point 4 rotation x, rotation y, rotation z 0. What about nodal point 2 and nodal point 3?
They will rotate.
They will rotate, but in which axis they will
Sir, only
rotate?
in x-axis. Y
Sorry?
and Z is 0.
Yes,
Z, Z axis.
nodal point 2 and nodal point 3. Wait. Yes, this is nodal point 2 and this is nodal point 3. It can rotate along x axis because this is your x, this is your y, this is your z. Wait. I have did a mistake. Please forgive me. This is your x, sorry. Yes, this is your X, this is your Y, and this is your Z. Due to this application of torque, about x-axis rotation is happening of the entire problem. Yes or no? If that is happening, then at node point 2 and at node point 3, only there will be rotation along x-axis. There will be some value of theta x for nodal point 2, theta x for nodal point 3, but theta y for 2 and 3 and theta z for nodal point 2 and 3 will be 0. Is it clear?
Yes, sir.
Yes, sir.
Okay. So please note all these things because I will not open this PPT again. Otherwise, some function will not work in ANSYS. Please note all these things and then you have to tell me during the analysis part. You have to tell me those values while importing. Please note it and then let me know. After that, I will open the ANSYS. Should I open or should I wait?
Sir, 2 minutes.
Okay, okay, okay. Arpan sir, are you there?
Yes, I am there.
Okay, okay, okay. Okay, students, let me tell you that in this design lab class, there are total three faculties are there who will be handling this class. Myself, Arpan sir, as well as Shudipto Dev sir. Fine. So it will happen like this. Say 1 week I am taking, another week some other faculty is taking. So most probably next week Arpan sir will take the class. Fine. I will also be there if by chance I am not there for some reasons, personal reasons or some official reasons. Fine. So next week Arpan class will conduct the class, and if there is any problem, I will help it out. Fine. Okay.
Okay.
Fine. So have you done? Are you done with the with noting of all these datas? Then I will close this PPT. Should I close?
Yes, sir. Yes,
Okay.
sir.
Fine, fine. So now let me open the ANSYS software. And in ANSYS, let me open the mechanical APDL part. Just give me a minute, it will take some time, 1 or 2 minutes to open. Can you see the ANSYS window?
Yes, sir.
Okay.
Yes, sir.
So again, let me give you a brief that this is your ANSYS window in which we will work. And if you minimize it, there is one more window, that is this particular window. This is in this window, you can see the commands. Whatever we are putting, whatever values we are putting, whatever thing we are doing in this, you can see your command. Okay. So very first step is to set the units. If you are setting, well and good. If you are not setting, then while inputting the data, you have to be careful. So how to set the units? You already know that in this, what has happened? Wait, let me again reopen it. Something is happening. Is it visible?
Yes, sir.
Okay,
Yes, sir.
so for if you want to set the units, then this is the command window. In this command window you have to write, that is slash, then units, units, comma. If you want unit in SI, you will write SI. If you want unit in CS, just erase it. You will write CGS in CGS unit. If you want units in MKS, just erase it and you write MKS and then enter. Then by default, your units will be saved in that particular. For example, if you have given SI, your default values will be in SI units. Fine. So here I am not setting the units. Let us solve it manually. We have to check it during the geometry that whether we are putting the values correctly or not. Fine. So very first step is, what is the very first step? Tell me. Already you have done
Sir,
two
edit
experiments.
job name.
Create node.
Sorry?
Sir, edit job name. Then
Yes, first of
title.
all, we have to go to file.
Title, sir. Title.
First, we have to give a name to this utility menu. For that, I will go to file, then
Change title.
change
Change job
job
name.
name. If you click on change job name, then in front of utility menu, you will see that this is the job name of the file in which everything will get saved. So click on change job name. Your file name will be, say, sorry, torsion, torsion underscore 1. In this file, everything will get saved. Then click on this new log and error file. Click it yes. If you click it yes, then in between, if you have did something wrong, automatically ANSYS will show you that yes, you have did something wrong. Solution cannot be processed. Again, you have to start from the beginning. Okay. Then click on OK. Fine. Now see, in front of utility menu, it has been written. See, it is written torsion underscore 1. Next step,
Title name should be changed.
we have to change the title name. For that, what is the algorithm? What is the
Sir, we
algorithm?
need to click on file and change title.
Click on file, change title, enter new title. So let us write torsional analysis of a stepped shaft. STEPPED. Stepped shaft means shaft of varying cross section. And then click on OK. Now, since you have clicked on OK, now that file name is not visible to you. If you want to make it visible, what you would need to do?
Replot.
Replot.
But there is no option of replot.
We
There is
need to
no
go
Sir,
to
option.
inside
plot
plot.
controls.
Plot, then replot.
Yes, click on plot, then click on replot. See, it is written torsion. Now that name has came, torsional analysis of a stepped shaft. Okay. Next step.
Sir, create node.
Preprocessor.
मटेरियल नोड में आएंगे क्या?
Sir,
मटेरियल
preferences.
डिफाइन नहीं किया, मटेरियल का पॉइजन रेशियो डिफाइन नहीं किया, कुछ नहीं किया, पहले ही क्रिएट नोड. वेरी फर्स्ट स्टेप इज, नेक्स्ट स्टेप इज व्हाट?
Sir, preference.
Preprocessor. Then we need to add the
No,
material.
no. Next step is preferences. Now, which type of problem you are solving? Which
Sir,
type of problem
structural.
you are solving?
Structural.
Structural. How ANSYS will understand? You are solving a structural problem or you are solving a thermal related problem. So always click on preference first, then click on structural, then click on OK. Next step.
Preprocessor.
Yes, sir,
Next
pre-professor.
step is I have to add the element of the shaft. In order to add the element, I will click on किस पे क्लिक करूंगा?
Preprocessor,
Preprocessor.
Element type.
Then after
element
preprocessor,
type,
Sir, element type.
element type.
element type. Okay. After clicking on element
Add,
type,
edit, delete.
क्या?
Add, edit,
Sir,
delete.
add, edit, delete.
Yes. Click on add, edit, delete. We need to add the element. उसके बाद
Add, add,
add.
add.
Click on add. Then this dialog box will open in which a library of
Sir,
element
beam.
type is there.
Beam and
You
188.
have to choose the type of element for the shaft. So which element will I choose?
It will be beam to node 188.
That means it is given in the problem. So that means in library of element type, you can see many elements are available. So in this, I will click on beam. In beam, again, two options are available. Which option will I choose? To
Sir,
node 188. It is given in the problem. If it is not given, then also by default we have to choose to node 188 because this particular version knows that for shaft we have to go for beam to node 188 element. So click on to node 188. Since for the entire problem G is same, mu is same, so this 2 node 188 element we have to take for the entire problem. So I will not change this element type reference number. If in the problem it has been told that the second element is having a G, some different kind of G, some different value of mu, then you need to change this element reference number type. For first element, G is say 450 megapascal, element number 1. For second element, G is 500 megapascal, element type reference number 2. Are you getting my point?
Yes, sir.
Yes, sir.
Then I will click on OK. See that beam has been added in this defined element type dialog box. Then click on close. चलो element define हो गया. उसके बाद
Real constants.
उसके बाद हम जाएंगे किसमें? हम जाएंगे रियल कांस्टेंट में. लेकिन रियल कांस्टेंट में होता क्या है? What real constant do in ANSYS?
Sir, we need to provide the value of G as well as the value of mu.
That is not there in real constant.
sir,
Real
material
constant does
properties.
not tells you that in real constant you have to input the value of G and mu. What does
Sir,
real?
material property.
Yes, that is the area of the cross section. That is the area of the cross section. Here I can see that my shaft is made up of circular cross section. So I need to give the diameter of the circle. If I give the diameter of the circle, and then I know that area is pi by 4 into d square. It can calculate. But by default, for torsional analysis of a shaft, for beam to 188 element, this real constant is not defined. It is inbuilt. Inbuilt it is defined. You cannot add any kind of real constant. I will show you. See, let us click on real constant. Then add, edit, delete. Then I click on add. See, already it is present. Type 1 beam 188. Click on OK. See, it is written the beam 188 element type does not require real constant. Inbuilt it is there. Then close. All these things you have to write in your report also, and you have to take the screenshot also. Please keep all these things in mind. That real constant is of no use. No, it is of use. You have to write after getting the screenshot or after getting the color printout of this particular page. You have to write that since it is a torsional analysis of shaft, for torsional analysis of shaft, real constant need not to be defined. It is defined inbuilt in the directory. Like this, you have to write each and every comment while submitting the reports. And by I think okay. At least you can submit the handmade written reports. So I will give you the time when to submit. Fine. So click on close. Next step is what?
Material property.
Then in material properties, what ANSYS do? क्या करता है ANSYS material property? Yes, we need to provide the value of E, G and mu. Since E is not applicable for this problem, I need to apply G and mu. For that, click on preprocessor, material properties, then उसके बाद
Material models.
material models, then
Structural.
click on structural, then
Linear.
click on linear, then
Elastic.
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 Click on elastic,
Isotropic.
then isotropic.
Isotropic.
In the problem, it is very much clear that all the properties are same in all the directions. So click on isotropic. Now you can see one dialog box has opened, that is linear isotropic property for material number 1. Since a common material is there, I have to put the value of Ex and PRXY. Now in this case, Ex means your modulus of rigidity. Since there is no value of E, so I have to put the value of G in place of Ex. So can you tell me the value of G?
74.
Sir, 7E4.
20,000.
Yes, it is 70,000 Newton per millimeter square, but I cannot write 70,000 simply. There is a technique to write it.
7E4.
74.
Yes, 7E4. 7 into E represents 10 to the power 4. Either you can write it with capital E or you can write it with small e. 7E4. Value of Poisson's ratio, that is PRXY,
0.33.
0.33. Then, okay.
Sir, 0.33.
अरे मैंने गलत लिख दिया क्या? Okay, sorry. It is 0.33. Okay, then click on close. Okay, then close this dialog box. Okay, material property is defined. Next,
Section.
yes, I have to model the problem. Before model the problem, I have to give the section. That means I have to see what is the cross section of my problem. Cross section of my problem is circular, so I have to give that cross section. And can you tell me in that problem how many sections are there?
3.
Sections.
Total 3 cross sections are there of 3 different diameters. Correct. So click on sections, then
Beam.
yes, I will click on beam. Then
Common
in beam,
sections.
click
Common
on
section.
common sections. When you click on common sections, this dialog box will open, beam tool. In this, ID number will be what?
Sir, 3.
ID number 3. क्यों 3 क्यों लिखूंगा मैं?
Sir, there will be three IDs
Yes,
because
sir.
all diameter are
Yes,
three different diameters.
not an issue because one by one I have to import the diameter. So for the first element, ID number is 1, diameter is what? For the second element, ID number is 2. What is the value of diameter? So let us keep ID number 1. Name you can write circular cross section. So cross section 1. Cross section -1. Subtype, what I will choose in subtype? What I will choose in subtype?
Sir, circular.
Yes, but there are two options are available, hollow circle and solid circle. Which circle will I choose?
Solid.
Solid
Solid.
circle. So there's this black spot circle. Choose it. Now you can define this or you can generate this circle in ANSYS either by radius or by normal and tangent. So since in the given geometry diameter is given to me, so I can easily evaluate the value of radius. Tell me the geometry radius of the first element.
50.
50 what? 50 mm.
Yes, sir.
So write 50. Then what? उसके बाद
Apply.
apply. Yes, apply. Then next ID number will
ID
be
number 2.
2 for second element. ID number 2, cross section 2, CROSSSECTION, cross section number hyphen दे देते हैं, -2. Subtype is again circular. Radius of the second element is
40 millimeter.
40. So write 40. Please keep this thing in mind. You are representing distance in terms of millimeter. So whenever you are representing stress, that should be Newton per millimeter square. You have to make that conversion because we are doing it manually. We have not set the default unit in the ANSYS. Then again click on OK or apply.
Sir, apply.
Click on apply. Okay. So next for third element ID number.
3.
3.
ID number is 3. Name of the cross section is CROSS cross section -3. Subtype circle, solid circle. Radius of the third element
25.
25 mm. 25 mm. Don't say 25, say 25 mm. Every time say the correct sentence. अब okay या apply?
Okay.
Okay.
Okay, fine. Now, if you want to see the preview, whether it has generated or not, then again click on common sections. Then which option we will click to see whether it has been generated or not?
Review.
Preview.
Preview. Click on preview. This is the cross section. Since all the three cross section will overlap, so it has not been shown over here, but after analyzing it will be shown to you. And if you want to see the mesh view, see in one speciality of this torsional problem is that here no need to divide the entire element into several small elements that we have did in the beam itself. This software will itself do the division part. Fine. So if you want to see the mesh view of the cross section, just click on mesh view. This will be the mesh view of each particular element of the cross section. Close it. Now you want to remove this entire figure.
Plot
you
and
want to
replot.
Go back to the black screen in order to draw your geometry. For that, what you will do?
Sir, plot and replot. Plot, replot.
Yes, click on plot, then click on replot. Fine. So next step is what?
Modeling.
Modeling.
Yes, we need to model the geometry. For that, click on preprocessor and ढूंढो कहाँ पे modeling है. Modeling. Then next,
Create.
Okay. Next,
Nodes.
nodes, because we are creating through nodes. Earlier we have given the coordinate points of nodes only. Nodes, then
Inactive
Inactive.
CS.
Inactive CS.
active coordinate system, because we have assumed a common coordinate system for the entire problem. Fine. Now see, one dialog box will open. In this dialog box, you have to substitute the coordinate points of all nodal points. So node number will be what? This is what? This
One.
value. Node number is 1. Coordinate points
0, 0, 0.
0, 0, 0.
0, y0, Z0, उसके बाद ओके या अप्लाई?
Apply.
अप्लाई, अदरवाइज छोड़ देगा. देन नोड नंबर विल बी
2.
2. कोऑर्डिनेट पॉइंट
450 00.
450, y और z में ऑलरेडी 0 है. देन अप्लाई. थर्ड नोडल पॉइंट कोऑर्डिनेट
850 0
कितना?
3.
850.
850. 850 00. Again apply because we are having total 4 points. This is the fourth nodal point. Coordinate will be
1350.
1350. So 1350. I remember these are all these things in mm. 135000. Now click on OK. See, 4 nodal points have been generated. You have to take the printout of this figure and you have to write the comment. What is 1, what is 2, what is 3, what is 4 in your page. Chalo, next step is what? Next step क्या है?
सर एलिमेंट्स.
Yes, in between 1 and 2 अब आपको एलिमेंट ड्रॉ करना है. In between 2 and 3 एलिमेंट, in between 3 and 4 एलिमेंट ड्रॉ करना है. So क्या करेंगे फिर? नेक्स्ट स्टेप क्या है? How you can draw element? What is the next step?
Modeling.
Yes, you have to click on modeling.
Create.
So click on, first you click preprocessor, then modeling, उसके बाद
Create.
click on create, then
Elements.
click on elements, then
Auto numbered.
yes, you have to click on because element attributes already you have given. So this is element auto number, then
True nodes.
yes, click on through nodes. That means your element will pass through some nodes. Next, what we will do? क्या करूंगा next?
Sir, we will pick two nodes.
Yes, we will pick two nodes. That is, first we are creating element number 1. So just click on first node and click on second node. उसके बाद क्या?
अप्लाई.
Yes, click on apply. So first element is created. Then click on second node and click on third node. Apply. Second element is also created. Click on third node and click on fourth node. Then click on either apply or OK. Both are same. So the entire element is created. In between 1 and 2, element 1 is present. In between 2 and 3, element 2 is present. In between node 3 and 4, element 3 is present. Is it clear?
यस सर.
Yes, sir.
Okay.
Yes, sir.
नेक्स्ट स्टेप क्या है?
Sir,
चलो
machine.
आपने मॉडल कर लिया. अभी दिख नहीं रहा है सर्कुलर क्रॉस सेक्शन, लेकिन दिखेगा थोड़ी देर बाद दिखेगा, अभी नहीं दिखेगा. बोलो नेक्स्ट स्टेप.
Sir, machine.
सर मेशिंग.
मेशिंग मैंने बोला इसमें मेशिंग नहीं करेंगे, ये अपने आप लेगा मेशिंग. टॉर्क के प्रॉब्लम में मेशिंग नहीं करते हम लोग, अपने आप ये मेशिंग ले लेगा.
Tensor loads.
Yes, you have to apply the boundary conditions, that is the rotations which are fixed and the loads. Here the load is in the form of moments that you need to apply. So how we will proceed for that? इसमें
The preprocessor loads.
प्री प्रोसेसर लोड्स. ठीक है, जाता हूं मैं प्री प्रोसेसर में. फिर मैं लोड्स में गया. फिर
Define loads.
डिफाइन लोड्स, देन
Apply.
Apply.
अप्लाई.
अप्लाई, ठीक है, अप्लाई में गया, देन
Structural.
Structural.
यस स्ट्रक्चरल, ठीक है, चलो स्ट्रक्चरल पे क्लिक किया, देन रुको इसको
Force
क्लिक,
moment.
फोर्स से
Force.
पहले डिस्प्लेसमेंट फिक्स करो, तो इसमें क्लिक करोगे,
Displacement
क्लिक ऑन
Displacement.
डिस्प्लेसमेंट, देन
on nodes.
ऑन नोड्स, ओके, देन
Sir, no
First and
nodes
last
clickable, but
nodes.
first and
First
last,
and
1 and 4.
click the first node and click the last node, उसके बाद
Okay.
ओके नहीं, ओके करेगा तो हट जाएगा, तूने अब यहाँ तेरे को यहाँ पे वैल्यू देना है कि वो फिक्स है, वैल्यू
Apply.
देने के लिए
Apply.
अप्लाई, फिर ये विंडो आएगा, अगर ओके करेगा तो ये विंडो नहीं आएगा, क्लियर है? सो कैन यू टेल मी, सो व्हाट आर वैल्यूज वी विल गिव?
Sir, rotation Y and rotation Z
अरे नोड
along
1
with
है,
the.
नोड 4 पे,
सर ऑल DOF होगा क्योंकि हर
yes,
डायरेक्शन में एक कांस्टेंट है.
node 1 and node 4 is fixed throughout, so all the rotations along all the axis is fixed, that means all degree of freedom, and then click on, उसके बाद क्या करूंगा,
सर
ओके,
क्लिक ऑन ओके.
Okay. Okay.
सी इट इज फिक्स्ड, दिखाई दे रहा है?
Yes, sir.
चलो, नेक्स्ट इज एप्लीकेशन ऑफ मोमेंट, उसके लिए क्या करूंगा, शुरू से बोलना
Force
मेरे
moment.
को, रुको रुको रुको, मेरे को पहले पूरा डिलीट करने दो, तब जाके आप सीखोगे। ओके, हाँ बोलो, नेक्स्ट इज,
सर प्री प्रोसेसर लोड्स.
यस प्री प्रोसेसर, रुको 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 धीरे धीरे, हाँ, देन लोड्स, देन
सर डिफाइन लोड्स.
डिफाइन लोड्स, देन
अप्लाई.
अप्लाई, देन
स्ट्रक्चरल.
structural, then
देन सर फोर्स बाय मोमेंट.
yes, very good. Since moment is acting, because torque is a moment which produces a twist in the body. So click on force oblique moment, then
On nodes.
ऑन नोड्स.
on nodes, then
2 and 3 we need to pick.
we have to
Separately.
pick node 2 and 3. Will I pick node 2 and 3 at a time or individually we have to do?
सर इंडिविजुअली बिकॉज
Yes,
बोथ मोमेंट आर डिफरेंट.
because sense is different, value is different, so you cannot take both 2 and 3 simultaneously, what you have did for the rotation part. So let us pick first node 2, then click on
Apply.
what, click on apply. So if you see, one dialog box will open. In this dialog box, on this direction of force oblique moment, fine, if you click on this symbol, many options are there. Which option will I choose?
सर fx and value will be negative.
fy, fz, mx, my, mz. fx, fy, fz, mx, my, mz. Which value will I choose?
सर mx.
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 mx, that is moment acting along x direction or x axis, mx. Value, here you have to give the value of that moment, that value with sense also. So first tell me the value.
3 E3.
3,
सर 3 kilonewton
3
मीटर है.
सर -3 E6
दिया किसमें है, न्यूटन मीटर या किलो न्यूटन मीटर, किसमें दिया है?
Kilonewton.
Kilonewton meter.
Kilo Newton meter. You have taken distance in mm. You have to convert that meter into mm. You have to convert the kilonewton into Newton and then tell me the value.
So 3 into 10 to the power 6
E6.
Newton mm, and it will be minus 3 into minus 3 E6.
Minus 3 E6. Okay.
Yes, sir.
minus 3e6, so minus 3e6, फाइन। उसके बाद क्या?
सर
Okay.
ओके।
अप्लाई कर दो, देखो लग गया इस डायरेक्शन में। ओके कर दोगे तब भी लग जाएगा, कोई दिक्कत नहीं है, ठीक है। कैन यू
सर
सी
टू एरोज
द
मतलब मोमेंट।
हाँ, yes, this double arrow represent movements. It is not possible to show it because it is the front view, no, not possible to show it that rotational moment. So this double arrow represent at point 2 moment is acting. Clear?
Yes, sir.
Okay. Next is we have to choose nodal point.
3.
3. Let us choose 3. Then click on apply. Then again this dialog box will open. In this lab, direction of force oblique moment, many options are there. Which option you will choose?
MX.
Again you have to choose MX because it is the moment is acting in X direction. Now the value of the moment
Plus 26.
plus, no need to give plus. If you give it 2e6, fine. Okay, so let us write 2e6. Click on apply or OK. See, done. Can you see? Can you observe in the diagram that at node point 3 we have applied the moment?
Yes, sir.
Okay. So click on OK. Done. Just minimize each and everything. Next step.
Finish.
Finish nahi, solution. Next step is solution. You have modeled the entire problem, so click on solution. Then
Solve.
solve the problem. Click on solve. Then
Current ls.
current local solution, because we haven't imported from any file, so we will not click from local solution files. So click on current local solution. This dialog box will open. If you click on OK, then that window will come. That solution is done. If it is not coming, that means error. OK. See, this dialog box has came. That solution is done. That means I have modeled my entire problem with correct loading condition, with correct boundary condition. Otherwise, here ANSYS will write that some error is there in the problem. Again, repeat it. So let us close each and everything. Fine. Okay. So solution is done. Let us close everything. Now I want to see the view, how the distorted shape will look alike. For that, what I will do?
General post processing.
Yes, click on general post processing. General post processing in ANSYS means you can view the final result of your problem. So click on general post processing, then
Plot results.
plot results, click on plot results, then
Deformed shape.
deformed shape.
Contour plot.
Click on contour plot. Okay, we will click on deformed shape also, not an issue. Contour
Animate
plot.
solution. Or
Then
nodal.
in contour plot,
Nodal solution.
Nodal.
nodal solution. And then in nodal solution, degree of freedom solution, that means each and particular node, how much it has rotated, that we want to see. So click on degree of freedom solution, then see many things are there. Which one I will choose?
Sir, displacement vector sum.
Why again I am telling you, torque will not create displacement in the nodes.
Yes, sir. Yes, sir. Yes, sir.
So
Rotation, it will be rotation.
Yes, rotation vector sum. You can choose x component of rotation also. So what it will give you? It will give you only the x component. If you choose rotation vector sum, that will be under root of x square plus y square plus z square. So choose on rotation vector sum. You want to see the deformed shape only or deformed shape with undeformed model?
Deformed shape with undeformed model.
It is up to you. If it is up to the if I want deformed shape only, I will click on deformed shape. If I want deformed shape with undeformed model, I will click on it. So let us click on it and then click OK. See, you have got the results. Since it is the front view, you will not be able to see the distorted shape. Is it clear, all these values?
Yes, sir.
Fine. Okay. Now, in order to see the distorted shape of the problem, what I have to do?
Sir,
What
plot
I have to
controls.
plot controls. Very good. Plot controls में गए. ठीक है. उसके बाद
Sir, animate.
हाँ, अभी मैं एनिमेट नहीं करना चाहता. अभी मेरे को देखना है. डिफॉर्म्ड शेप देखना है. एनिमेट तो बाद में. ठीक है, एनिमेट कर सकते हो, लेकिन पहले मेरे को डिफॉर्म शेप देखना है. तो उसके लिए क्या करूंगा?
Style.
Yes, click on style. Then
Size and
Size
shape.
and shape.
yes, click on size and shape. Up, if you click
Sir,
on size and
on.
shape, one dialog box will open. In this dialog box, you have to do something. What you have to do?
Sir, click where off is written.
That means this display of element. You
Yes,
have
sir.
to click on the display of elements. So far, see, we haven't done this step. So I cannot see the distorted shape of the model. Only I can get the values. How much will be the rotation? Those values I am getting. So you have to click this display of element button on. If you click this button on, then after that, इसके बाद क्या? Click on OK.
Okay.
दिखा? This is the front view of the distorted shaft model. And this, all these numerical values represents the rotation. Since rotation at the two fixed ends are 0, blue line, and these values represent, that means this 0 to 0.244 e to the power minus 3. That means in this that means from this point to this point of the element, rotation is varying from 0 mm to this particular value of mm. Critical point of rotation in the entire problem is this particular point, red point, and that values varies from 0.001954 mm to 0.002198 mm. That means if you consider the entire stepped shaft, then this particular element, starting point is this point, ending point is this point, your critical rotational value will vary from 0.00194 to 0.002198. So this is the front view of the model. Let us check the isometric view. So in the right hand side, click on this isometric view. This is the isometric view. Can you see?
Yes, sir.
And can you see in how many elements they have divided? All these blue, light blue, red blue, yellow, orange, red color line. All these things represents that inside the shaft, if you divide it into many number of elements, each and every element will be subjected to how much amount of rotation along x-axis. This is the isometric view of the model. This is the oblique view of the model. This is the front view of the model. This is the right view of the model. In right view, you can see the cross section of the model. Can you see? This is the cross section. Meshed cross sectional model. Can you see?
Yes, sir.
Yes, sir.
So
Yes, sir.
this smaller blue color circle one is which diameter?
Sir, 25.
25.
Yes. And this one is which diameter? This middle cross section
Sir,
is?
40.
40.
40.
Yes. And this outer one, which is the most critical region, is which diameter?
50.
Yes. This is the cross sectional layout of the problem. Fine. Okay. कोई डाउट यहां तक किसी को?
No, sir.
No, sir.
Okay. So let us list. Now we have to list these results. Fine. This rotational vector sum, let us list it. For that, कहाँ जाऊंगा? Where I will click? Plot मैंने देख
General
मुझे list
post
करना है.
processing,
General post processing. Okay, then
list results,
list results. Then
nodal solution,
nodal solution. Okay, click on nodal solution. Then
degree of freedom solution,
yes, click on degree of freedom solution. Then
rotation vector sum,
you can click on x component of rotation also, but in ANSYS in finite element, we are interested in detailed analysis. So let us click on rotation vector sum. It will give you the x component also, y component rotation, z component rotation, as well as the vector sum of rotation. That is under root of x square plus y square plus z square. So click on rotation vector sum. उसके बाद
okay,
okay. See, this command window has opened. Node 1, node 2, node 3, node 4. Rotation X. We have already told, I have already told you that in Y and Z direction, no rotation is happening. So for all the nodes, rotation Y and rotation Z is 0. And this is the rotation vector sum under root of x square plus y square plus z square. And the maximum and minimum value is also given to you. Minimum value is 0 and the maximum value is minus 0.21979 into 10 to the power minus 2 radian. This rotation theta, if you remember in strength of material, you solve it in radian. Fine, so it is in radian. Clear है? कोई doubt?
no, sir.
Okay. So let us close it. You have to take the printout of this particular file, for the cross sectional area. जो area में से वहां पे जो दिखा रहा था meshed view, उसका लेना पड़ेगा आपको. Fine. So let us close each and everything. Fine. Okay. Next is we want to get the reaction solution. That means both the two ends are fixed. We need to get the moments and rotation. For that, what I will do?
General post processing,
General post processing. Okay. Next. Next.
element table,
Reaction solution. Element table. No, there is no reaction solution in element table.
sir. I think we need to define the table.
Element data. Okay. Ooh. wait, general post processing, then list results. In list results, there is
Reaction
yes,
solution.
reaction solution. Click on list results, then in list results, click on reaction solution. Now, what you want? What is happening in the problem? In the problem, torque. The problem is subjected to torque. So you need to see the torque value. For that, what you will do, you will click on all structural moments. That means at each and every node, how much is the moment or how much is that torque that it will give you. So click on all structural moment, then click on OK. See, nodal point 1, which is the fixed nodal point, how much is the torque? It is given. For nodal point 4, how much is the torque? It is given. Clear?
Yes, sir.
Next is,
Yes, sir.
now we want to see the animated view of this problem. For that, what we will do? बोलो एनिमेटेड व्यू देखना है इस प्रॉब्लम का तो क्या करूंगा?
Plot
Sir, plot
controls,
control, animate.
animate.
Plot control and animate. Okay, click on plot control, then click on animate. अब animate में तो बहुत सारा ऑप्शन है, किस पे क्लिक करूंगा?
So, deformed shape.
Deformed shape. Deformed shape. Now if you open, click on this deformed shape, this dialog box will open. That is animate deformed shape dialog box. Let us create number of frames 20. Then slowly it will, if you create more number of frames, easy to analyze that each and every element how much it is deforming. So let us make this number of frames to create 20. 20 time is 0.5 seconds. And what do you want to see? You want to see the deformed shape only, deformed plus undeformed shape. Let us see the deformed shape first. So click on deformed shape, then click on OK. Can you see? Observe. Can you see the difference?
Yes, sir.
Since you are applying moment torque over here and applying torque over here, so only this much portion of the element is changing. Here no change, fix. At this point fix, no change. Is it clear? कोई डाउट?
No, sir.
बाकी लोगों को कोई डाउट, किसी को कुछ? हेलो. Okay.
No, sir.
Let us stop.
Clear, sir.
Close. Now again we click on plot controls, then animate, deformed results. On clicking on deformed results, you want to see the degree of freedom solution, rotation along x-axis, how much is each and every node is rotating. So click on deform solution. On this degree of deform solution, click on rotation x, ROTX. Click on OK. See how much rotation is acting. This is the deformed shape of that rotation at each and every node and at each and every element. Clear? Hello.
Yes, sir.
Yes, sir.
Okay. Close. Again click on plot control, animate, deformed shape, deformed plus undeformed, okay. See, the one which is increasing, that is the final shape, and the one which is constant, that is the initial shape of the problem. Can you observe the difference?
Yes, sir.
Yes, sir.
Okay. Now, can you tell me that for this particular problem, shear stress will act since a torque is acting? Can you tell me in which plane the shear stress will act? See the diagram.
YZ plane.
YZ में कैसे आएगा मेरे भाई? Y में कुछ लगा ही नहीं है. It will be XZ plane, because in XZ plane, this is your body and you are applying a torque of 3 and 2 kilonewton meter. So if you want to find out the value of shear stress, you have to click on XZ plane. So plot controls, that is animate, deformed results, stress, shear xz. Okay. See, this is the animated view of shear stress acting in the entire element. Clear? This animated view clearly shows which portion is very critical and which portion is less critical with the help of these colored lines. Clear hai? Hello.
Yes, sir.
Okay. So let us stop it over here. Then again I will go to generate post processing, list results, nodal solution, and we are interested in getting the results of stress. Which stress? That to XZ shear stress. Click on OK. No data is available for the selected models or data location. Some problem is there. That means beam oblique pipe element are detected in the selected element set. They are ignored in the nodal averaging. Okay. No data is available for the selected model or data location specifications. That means we haven't imported anything, right? I think so. Okay. Then click on general post processing. Then click on plot results. Then click on contour plot. Click on nodal solution. And then click on stress. And then click on XZ shear stress. Click on OK. This is the shear stress value for the problem. Yes, this will be the correct method. Is it clear? This is the shear stress induced in the entire element. Any doubt?
No, sir.
Okay, this is the isometric view, oblique view of the shear stress, front view of the shear stress. This is the cross-sectional view. How much shear stress is acting and at which point. Any doubt? Hello.
No, sir.
Okay. With this, we have ended this experiment over here. Fine. We will again meet in the next class. I'm not starting the next experiment because it will take time. It will take again 1.5 hours. So better not to start. So with this, let me close the window. I will not save it. Okay, fine. So with this, we have ended the today's experiment over here. If anyone is left to give his or her attendance, you can give the attendance. And then in the next class, we will meet up with the new problem. Fine. And the next class, I think Arpan sir will be there. He will guide you. I will also be there. If any problem is there, I will. I am also there. Fine. So okay, then if anything you need to ask, you can ask, or else you can leave the meeting. Thank you.
Thank you, sir.
Okay.
Thank you, sir.
And probably in the next class I will tell you. See, I am giving you this month time. If you can manage this software from somewhere, it will be good. In the September month, I will give you the deadline of submission of all these lab assignments. Most probably we will be solving. So far we have solved 3 assignments, lab assignments we have did. We will be solving, I think, 4 in on an average 7 to 8 problems we will solve in for this lab. Fine. So September month, uh, next class, let Arpan sir completes that experiment. Then I will give you one deadline. Maybe mid of September, I will give you one deadline for submitting these 4 assignments in Google Classroom itself. And then after that, by the end of October, I will tell you to submit the remaining 4 assignments of this lab. Yes, altogether I think we will be doing 7 or 8 experiments. With this, we will conclude this lab. Okay.
Okay, sir.
So I'm giving you this month time. Please try to arrange the cracked version. I'm not telling you the original version. Fine. Please try to get the cracked version if it is possible. Or if anyone is lying near to college, so if you want, you can come in the college. In our lab, it is there. Or you can call me. I can also come. Or you can call Arpan sir. He can also come. You can get the cracked version of software from the college itself. In our that AutoCAD lab, it is there. Okay then. With this, I am ending the meeting over here. Fine. We will again meet in the next week. Thank you.
Thank you, sir.
Okay.
Thank you, sir.
Hmm.